Hey everyone, if you're wondering what Bigquery is and how to work with it, then this is the video for you. In this video, we will introduce you to Bigquery with its core functionalities. Mostly we will do hands-on to help you get started. So without any delay, let's begin. So what is Bigquery? Bigquery is one of the top choice data warehouse in the market. And now it is not even just a data warehouse. It has evolved and became more of an analytics platform with a lot of things have been integrated with it. If we look into its definition, then BigQuery is a fully managed AI-ready data analytics platform. All you should know is you can store thousands of terabytes of data and you can query it with a super fast speed. Another important point here to mention, it is fully managed. It means it is fully managed by Google and user don't have to worry about the disk storage and the compute resources. User can just upload the data and start querying, and the infrastructure behind it will scale up and down as needed. And of course, users will be charged based on the amount of data stored and the data processed in querying. In free tier, users can store 10 GB of data and run up to 1 terabytes of queries for free per month. That is good enough for us and for everyone to explore the BigQuery capabilities. Now let's see BigQuery in action. And you can start by just going to cloud.google.com. For sure you need a Google Cloud account and you can create one for free. Once you are logged in, you can just see the console here, just hit the console button, and this is the entry point for the Google Cloud platform. You can see all the products here, view all products. You can also access them from here, solutions, all products. And one of the services provided by Google is BigQuery. You can see here it is also listed. If you're not able to find it, you can directly search here, BigQuery. But before that, once you're logged in with your Google account, the first step we need to do is start a project or create a new project. So just go here and this is the new project. Just define the project name. There is no organization needed as such for us, and then hit the create button. I have already created one project, BigQuery tutorial, and make sure that the project that you have created should be up here. That's the project we are going to use to explore BigQuery. Another step for most of the services is that to add a credit card and enable the billing for that project. But that is not mandatory for BigQuery. That's called sandbox project for BigQuery, where we can explore the BigQuery capabilities without enabling the billing account. Once your account is created, and now we need to enable the BigQuery API for this project. APIs are the way administrator can control which service is enabled or can be accessed inside or through this project. So we want to enable the APIs of that BigQuery. We can do that by going to API and services as well, where we can access all the other services and enable and disable whichever the service you want. Or we can directly go to BigQuery and it will show us. If the API is not enabled, it will ask us to enable the API. So you can see it is asking us to enable the API. Just hit this button and we will see that BigQuery API is enabled. Then only we can access the BigQuery console. So now we are inside BigQuery. You can see the project is correctly selected, BigQuery tutorial. Here we can see that we are in the sandbox because we have not enabled the billing for this project yet. It is asking us to set up the billing to upgrade to full BigQuery experience. So some limited exposure we will have of BigQuery. And here you can see we are in BigQuery Studio. There are multiple tabs here like BigQuery data transfer. All the queries that we will schedule will be present here. Schedule queries, analytics hub, data form, and multiple tabs here. Maybe these tabs we will explore some other time. And then we have this explorer. So here we have all the assets that we have created or we have access to in BigQuery will be listed here in hierarchical fashion. So this is our project ID, BigQuery tutorial, and then a number. And then we have these 4 kinds of assets are possible. So one is queries. If we save any queries, we will see them here. Then we can create notebooks, and those will be listed down here. Then data canvases and external connections, those will be listed down here. Currently there is nothing in it, it's an empty because we just started. And then we have this add button here using which we can create an external connection maybe from S3 or Azure. We can load the data from cloud storage, or we can upload a local file from our machine. One important source from this list is this public data sets. So public data sets are actually the data sets which are real world data made public by some individual or some organization, so for which is available for free to us. And some real world data we can start analyzing directly in BigQuery. So this is really cool. This is something you can explore. Then the first step would be for us to start with creating a data set. So just go here and we have this create data set. All we have to do is just provide the dataset ID. So I'll just give demo dataset. All of these things we can keep as is. If we want to look into, then this is the location type. We can keep our data in one region, maybe in US East 1, or there are multiple regions available across the world. Or we can have multi-region, so US or Europe. So I'll just select US by default. Then we can have default table expiration time. So any table if we create in this data set, what is the default expiration time you want to set? Then we can attach tags, and then we'll just hit the create dataset button, and here we have demo dataset is showing up here. It got created. You can see the location where the data will be stored is US, and we can see when it got created and what is the dataset ID. Then the very basic thing we can do is create table. We can start creating table in this data set. We can share this data set. We can control the permissions, who has access on this data set. We can copy and delete some basic. These are some of the basic functionalities that is present. So table is like a basic entity which hold the data in BigQuery. So we can start by creating one table here. There are multiple sources, as you already saw. We can source the data. We can start an empty table. We just have to define the schema, and that's it. So there will not be any records in it, definitely. And then we can upload the data from Google Cloud Storage. We can upload from our local machine. We can upload a file or Google Sheet from Drive. We can upload from Bigtable as well. We can connect with Google, Amazon S3 and Azure Blob Storage as well. Right now I'll just do upload from my local machine. I have got this dataset Olympics.csv. It's a CSV format. So file format is already selected as CSV. There are multiple file formats available: JSON, Avro, Parquet, ORC. We can upload those. And then all we have to provide is the table name. So I will give Olympics data. This is going to be a native table. And then we have to provide the schema. So schema, if we are very rigid on the column name and the column types, then we can define the fields by ourselves. We have to provide the name, the type, whether it is nullable is possible or not. If we are not very keen on the on the data types and column names. Then we can ask BigQuery to auto detect the schema. It will use first row as the header that will contain the column names, and the column data types will come from the data. It will read the data and it will try to assess which data type it can assign to. Then this partitioning and clustering, these are some optimization techniques. When our data gets bigger and bigger, then we have to define the table in such a way that when somebody query the table, they should their query performance should increase. They should get the data much faster. But for our case, we can start with no partition, but there is a possibility to partition the table based on the ingestion time that when the rows or the data comes in the BigQuery. Or we can also partition by the columns, certain columns, maybe the date time, timestamp, or date, or integer as well. Then clustering is something where if we can provide up to 4 columns in clustering, and in those partitions or even in unpartitioned table, the data will be sorted based on this column. It's like data is present as order by and then clustering columns that we provide. So if we put that column in our where clause, the retrieval and the search of BigQuery will be faster, and we will get our data faster out of the BigQuery. For now, we'll just we can ignore them and just hit the create table. Okay, so now our table has been created. We can see go to table here, or it is showing up here as well inside demo data set. So this is our data. Now we can see the schema. We are on this table, Olympics data. Alright, so you can see the schema is present here. You can see all the columns, which the column names has been taken from the first row, the header row of the CSV file, and the data types has been identified based on the data that is present in the file. If we want to take a look at the CSV file that I uploaded, so this is our CSV file, ID, name, sex, age, height, weight. So this is basically Olympics data that is, I got it from the Kaggle, and yeah, so this is the data that I'm using, and it is basically listing down all the names of the participants in the Olympics, and what is the outcome, in which event they participated, which sports they participated, in which city that event happened, and what was the season, what is the year, the games, and the team is basically the country name, and what is the weight class for them, and what is the medal they got from that event. So this is the data that we just uploaded, and these are the columns. We can see this schema. We can also edit the schema. We cannot add columns in between, but we can add columns at the end if we want to. If we have certain requirement, then we can add the columns at the end only, and for the existing records, definitely those columns will have the null values. So now we have this details tab, which provide the table information, what is the table ID, when it got created, when it got modified. All of this information is present here. We can see the number of rows. So there are 70,000 rows in this data that we uploaded, and it is taking 10 MB, 10.2 MB storage in BigQuery. Then we have this preview where we can actually see the data and the records. So you can see the age is coming up as 20.0. So that is a float number that we have. And you can see the medal as well, the silver and null. You have silver, gold, bronze. These 3 values will be there for the medal. We can verify that. We can verify that from when we explore this data. There are more things available like data table explorer, insights, lineage, data profile, data quality. We can explore them maybe in some other videos. Apart from that, we can also control the permissions, control the access, who can access to this table through this tab. We can add the identity and add the principal. We can copy this table, we can take the snapshot, and we can delete, and we can definitely export it to Google Sheets. We can export it to Looker Studio, To create the dashboards, we can export it to GCS, Google Cloud Storage. And the basic thing that we will do is query it. So I will just do and go query in the new tab. All we have to do is just select a star. So this is the very basic query that we can run. This is the place where we can write any query. And before running the query, we should look for this green check mark. If there is any query in our syntax or any query, maybe the table is not present, or certain column that we are getting from that table is not present in, actually not present in the table, or some typo or some mistake you made. So you can get that from here. Maybe let's suppose I put a space here and it will show that not found. So this table is not found, right? So if I correct it, yeah, so this is something we should look into before running the query. And then this message is also important. Here it will show us that how much data you are going to scan by running this query. So when you are dealing with huge data, terabytes of data, you should always look up how much data will get scanned when you run this query. If there is some optimization you should do, or you can do, or maybe the table is a partition table. So you should look into how you can optimize the query and how you can reduce this number. Once you are satisfied with that, you can just hit the run button and we will get the data or the output or the result of this query here. So this is the tabular format and we are just seeing the top 50 rows here. We can also see the result in the JSON format. We can see the job information here, how much time it took, who submitted the job and all. And we can also save this result as a CSV file in Google Drive. We can just download the file, CSV, to a local file, or we can download the JSON file as well, JSON new line delimited as well. We can create another BigQuery table from this output. That is also possible. And then we have Google Sheets. We can export this data to Google Sheets and analyze in Google Sheets. Or we can just simply copy this data to clipboard and we can paste it anywhere. So this is the very basic query that we started with. We can try to analyze this data even further. Let's suppose I want to understand actually what this data that we are looking into. So the first thing would be, what is the time frame of this data? So we have the year column. So we can see what is the duration of this data. So I'll just do minimum of year and max of year. Yeah, so the data is coming from 1896 to 2016. So that's a very broad duration we have. That is good. We can also see the distinct teams. Okay, how many countries we have? So we have 827 countries. That is also very good. So we have a very broad data set here that we have. We can get rid of this limit 1000 now. Okay, maybe now I want to see the distribution of participants by age. So I can just go here and do select age, count of distinct name as participant count. We have to do group by 1 and let's do order by as well, order by age. Now hit the run button. Alright, so we can see there is a lot of null records we have. Let's suppose I don't want these null records in the output. So I'll just do where age is not null. Now hit the run again. And we can see, yeah, so we can see our data is come. Now we can visualize this data as charts as well in BigQuery. So you can see this is a very good distribution curve we are getting, and you can see the maximum count that we have, maximum number of participants. So those people have 23 age. For 23 age we have around 3.9, so nearly 4,000 participants, and the minimum that we have is 11 and the maximum that we have is 88. So this is a very good representation of our data, and we can convert it as a bar chart as well. We can also see the scatter plot as well. Apart from this, if you want to start and explore and create a dashboard maybe from this query or from this data, then you can just go with explore with Looker Studio, and we can create the dashboards in Looker. We can also explore this data with Sheets, with Google Sheets, and we can also start with Python notebooks as well. Let's suppose this query that I wrote is important and I want to save it. So we can just go here, save query, classic, and you can provide any name, maybe the age distribution query. And I can save it at my personal level so other people cannot see it. I can share this query and save it at the project level, or I can make it public as well. So I can just hit and save for personal level right now, and I can see all the saved queries will be present here, saved queries, and we have age distribution query here that we just wrote. If you want, we can share this query as well with some other people. We have to make it to public and just copy this link and share that link with other people so they can also access it. Apart from this, we can also store this query as a view, and we can create a view using this query. Save copy as view here. We just have to provide the data set. We have only one data set. Then we can provide the name for this. So we can give age distribution view. That's it. So we can see that view has come up here. Inside the demo data set, we have age distribution view. We can just go and see the schema. It contains only 2, age and participant count. And inside details, we can see the query as well. If we want, we can edit this query. And if you want, we can query this view as well. If I just do select a star, it will show us the same result. If required, we can schedule the queries as well. We just have to provide the name of the scheduled query. We have to provide when do we want this schedule to run or this query to run, or daily basis or hourly basis. And we saw that we can access all the scheduled queries from this tab. Apart from this, we have this more options where we have this format query. This is just, so that's what it does. It makes our query look good, and it format it, and it is easily readable. So what we did today is a very basic exploration of BigQuery. BigQuery is definitely capable of far more than that. We will try to cover more and more topics on this. Until then, see you next time.